This is Bill Sell with Crosstech Forums, welcoming you to another in our educational series that we have of executive level and networking types of programming. This particular webinar is related to a series that we do on the Health IT Insights Summit that takes place in Boston. And throughout the course of the year, we actually gather online with webinars. And today, we're very pleased to have with us, and I'd like to thank our friends at Blue Slate Solutions for joining us. The presentation is How to Succeed with Process Automation, the Zen of Automation, and our speaker is Blue Slate Solutions Chief Technology Officer, David Reed. David's been with the company since 2000, and he leads their consulting team, lending his expertise in security, compliance, web services, system integration approaches, enterprise architecture, QA procedures, and legacy modernization within healthcare. He also coordinates the Blue Slate consulting teams where they identify, evaluate, and adopt new products, tools, and techniques. So quite a bit of experience there. And David is actually a sought-after speaker. And in addition to this webinar and some of our other programs, he does speak at industry conferences like Java 1 and the Business Rules Forums on topics including secure web development and legacy modernization. And with that, I'd like to welcome you. David, please present.
All right. Well, thank you very much, Bill. Welcome, everyone. Good afternoon. I'd like to start off just explaining the title of this. We talk about the Zen of automation, and Zen to some folks might be a meditative technique. But what we're really talking about in the practice of Zen, it's about direct knowledge instead of book learning. And so hopefully what you'll get out of this is a lot of information based on our direct knowledge at Blue Slate from different projects that we've done, and we're sharing that information with you. So this is practical information, not theoretical information. So Blue Slate itself was founded in 2000. We do work throughout the business life cycle for projects. So we work with operations groups and their strategy teams, and then on the technology side with integrating solutions and building out those systems. We do a lot of work with BPM-related tools. Those are workflow engines from different vendors, rules environments, and data manipulation components as well. We've been lucky that we've been exposed to a lot of different verticals and the use of these tools throughout those verticals, and have seen just amazing productivity gains and other advantages to quality, et cetera, from the use of these products and techniques. So a lot of good stuff to get out of it. So our agenda today is to walk through, first of all, just some terminology and what we're trying to accomplish with computer systems. So we talk about the means changing, but the ends do not. We're still trying to get functionality out of computer systems. It's just we do it differently, and we'll talk about some of those differences. We'll then drill into some specific techniques and products. So the first is service-oriented architecture. There's a lot of discussion around that, and certainly have been a lot of presentations around that. We're just going to talk at a high level about what that means and why it's important as you start to leverage things like workflow and business rule automation. We'll then switch gears and talk specifically around identifying opportunities for the use of workflow, and then the same for business rules. And with that grounding then around what's the value to our business, we can talk about the actual automation of that process. So the products themselves, how they work, some of the things that are great about them, some of the things where there might be some challenges. We'll also explore industry-specific solutions. So there are workflow environments and rules environments that are pre-configured for a given vertical. We'll talk about the pros and cons of those. And then finally, we'll discuss briefly some ways that rule engines are being used that may not be quite as obvious, but certainly show a lot of the power of leveraging these things. So the means change, but the ends do not. And by that, what I mean is that the goal of workflow or business rules is to get the computer to do work on our behalf. And so if you look at those photos, we had a desire in society to get messages from one place to another. And it isn't that that has changed. We still want to get those messages, but the way we do it has changed. And hopefully what you'll see in this presentation is that the same is going on in technology. So why do we use computers at all? I mean, why even bother introducing them into our environment, having groups that have to maintain them, dealing with some of the risks around security, etc.? Well, a big one is that it gives us an easy way to access our data. Having information in file cabinets isn't particularly scalable. It can be difficult to find what you want. It's difficult for more than one person to gain access to that information. It can't be codified or indexed in multiple ways. So at a basic level, and where computers really started out, was just a way to house data. We also leverage computers because they're really good when we want to repeat a process or logic of some kind. So they do that really well. They remember how to do it once we tell them, and they do it the same way in principle every time. Computers are also really good at computation, at carrying out calculations and other types of logical processes that once we encode them using some language, the computer can carry that out. And then finally, speed. The computer can do things very quickly, and as long as we get out of the way, as long as we don't introduce a human into the equation as the computer's doing the work, it can take a process through from beginning to end very quickly. So that's what we're looking for out of systems, and where workflow and business rules can help us. Now, over time, we've changed the way that we essentially instruct computers. Back in the 1940s, computers were programmed physically by moving connections. And then eventually we started using low-level programming languages and moving the data around in a fairly direct way, but with software instructions. And then in the 1960s, we started to find abstractions that were useful in the development of those applications. And we could write instructions in a language that made more sense to us as humans, and then were translated into something that the computer could execute. And that continued through the 70s as we structured our programs, looking, again, for better ways to build these applications so they could be built in a way that was faster, where we could check them for quality. In the 80s, there was a big movement, the object-oriented development movement, that was supposed to really make it straightforward to create applications that were scalable and reusable. And in the 1990s, it was all about event-driven, that instead of having a set of instructions that always executed in a given order, we wanted to be able to process information from a user or another system that was a signal to us to do something, or signal to the system to do something. And now we find ourselves in a world with these engines, workflow and rules and content management systems, where the level of abstraction is very high. But with that abstraction comes a lot of complexity. We now need to move a lot of data around between dissimilar systems, and that creates a set of risks. So as we've increased the abstraction to get more capability, we've also increased some of the complexity that we have to deal with. So fundamentally, when we talk about programming a computer, what we're talking about is telling the computer what to do. And that falls into three major buckets. One is, when do I involve a person and allow them to input information? Another is to automate when a decision is made. And then finally, we have to do something with the data. We either create structured data or unstructured data. I can generate documents, or I can generate database entries, or read those database entries. And so at the bottom of the screen, those are two computer programs. The one on the left, if you've ever written BASIC, is a BASIC program, probably circa early 1980s. And then the program on the right is a workflow program. And that's the way we might actually envision building an application today. But fundamentally, those two things represent exactly the same set of steps, and they require the same logical thinking. So the task of programming hasn't really changed all that much. It's just the tools and abstractions that we use that have advanced. And as those tools have advanced, there are some things that have changed. We've moved from the micro to macro level. So talked about early on, we were programming computers using languages that required us to manipulate files and information at a very low level, and we've now moved up to a high level. So we've gone in our thinking from a micro level to a macro level. And the side effect of that is that it takes away our fine-grained control over what's happening, and we have to be willing to let go of some of that desire that as developers or business people who want very definite control over what something looks like or how it appears on the screen or where it is. We have to be willing to let go of that a little bit in order to get the advantage of this macro level of creating applications. These tools also now prefer that we think of solutions in terms of groups of users rather than individual users. It's easier in these tools to produce a set of processes or rules that apply to a large group rather than try to individualize them. It actually becomes rather inefficient to try and do that. Now what we get out of this is it becomes really straightforward to reuse these workflows and rules and such, as long as we understand that they're at a group level and they're at a macro level. We're not going to try and do things and have very precise control over them. The focus on goals is, as I alluded at the beginning of the talk, we need to be thinking about the ends. What are we trying to do, and not worrying about exactly how the computer does it. And we need to let the computer take care of the most optimal way to get that work done. Now this is still fundamentally programming. It still requires logical thinking. It isn't something that any business person is going to sit down with a workflow tool and just build an application, because we still have to do all that hard work of wiring systems together, getting the data from point A to point B and making sure it has the same meaning, dealing with errors that will always occur. All those types of things still have to be mitigated, and that requires someone who's really trained to deal with computer systems and understands their internals. So let's start off with a service-oriented architecture discussion. The service-oriented architecture becomes a foundation on which we can leverage a lot of different tools. Workflow and business rule engines are just a couple of examples of the things that we can do once we have a service-oriented architecture. But what is a service-oriented architecture, and why is it a good thing to have? And this picture actually isn't chosen by accident. This is a team, a soccer team. And a soccer team or any sport team tends to work the same way that we expect a service-oriented architecture to work. That is, each player actually has a set of skills or capabilities that they bring, just like our different computer system components bring some skill or capability. And the team members have to be able to communicate very quickly and efficiently, so they can't be confused as to what one of them is trying to do or accomplish. And in a service-oriented architecture, we need the same level of communication between the components so that there isn't a question as data is moving around as to what that data represents or what's supposed to happen to it next, so that it's actually very aligned. So if you understand that paradigm, then you really start to understand the power of a service-oriented architecture. Service-oriented architectures also are not new. We've been connecting computer systems for almost as long as they've existed. It's just the terminology keeps changing. So in the 1970s, we had a lot of data moving between mainframes, and we called that messaging. And if you've ever heard of MQ series or any of the queuing type technologies, those are all technologies that were very popular as ways to get data from point A to point B, usually in a guaranteed fashion between these systems. In the 1980s, there was a big push for client-server. We had database systems that had standardized ways that you could get to your information. And Microsoft created a technology called ODBC that abstracted that so that any application that could talk ODBC, could interact with databases through that, could essentially talk to any database management system and read and write data. In the 1990s, we started dealing with these object request brokers, and CORBA is certainly a standard that emerged from that and continues to be used to solve certain integration problems. Again, the goal was to be able to pass data, and really in this case instructions or logic, and share it amongst different systems. And then here in the 2000s with the web and the use of web protocols, we've moved to leveraging web services, SOAP and REST being the two that we tend to think about the most, as a way to, again, pass this data around between systems. But the goal is always just to get data and logic from point A to point B in a way that both systems understand what it means and can process it in a repeatable fashion. The technology isn't the issue. What really becomes the hard part of service-oriented architecture is the syntax. And so if you think about human communication, most humans can speak and most humans can hear. And yet that doesn't mean that any set of human beings can communicate, because we tend to have different syntaxes depending on how we were raised or where we live in the world. And so in this slide, we can see an example of a conversation, except this conversation would be a very difficult one for some people to have because there's a slew of different languages or syntaxes being used. So even though the mechanical aspects and the system aspects of a mouth and an ear are remaining constant, the syntax itself is in flux, and that then leads to some confusion and inefficiency. If we look at the way that's dealt with in a service-oriented architecture, the first answer that we always hear is that we're going to leverage XML. And this is an example of XML being used to represent a similar conversation. And if you notice, XML doesn't actually solve the problem. So this is an XML representation of a request for some data and then a response with the data coming back. Except we still don't actually understand necessarily what the request is or what the response is. So XML itself is a way to structure data, but XML by itself doesn't create a syntax that all systems would be able to consume. So there's another step that's actually required in making that useful, and that is to actually create a syntax. So in this example, what we've got is, again, XML, and XML is useful because it gives us a nice way to be able to parse something in a reliable fashion. There are system components that we can build once that can always take the message and get the pieces out of it. But we need that syntax, that metadata, so that meaning is applied to the data. So now we know where the name is and where the account number is, and it will always be labeled as such. And so we don't have confusion about what the data represents. And that is probably the hardest part of getting an SOA right and having it work long term, because that requires an agreement amongst all participants who are sharing this data on what that metadata, what that syntax looks like. And really what that leads to is something that's normally referred to as a canonical, which is just a fancy way of saying that it's a rule, it's the standard. And we talk about canonical models, and we've had canonicals for years. We've had canonicals in our databases that represented as how we structure our database. It becomes the schema. In the object-oriented world, we've had canonicals, which were how we laid out our classes and dictated where the data was and what the relationships were between that data. And now with XML, we can create schemas that, again, say here are the rules, here are the elements you can use and the attributes they contain and how they nest with each other and what those terms mean. And in order to accomplish that, what a business actually needs is a governance process that can define terminology, define this canonical, and make sure that as time goes on and business needs change, that canonical gets adjusted. Because it will not be static. But this, as I said, is the most challenging part of getting an SOA correct. The plumbing, the connection of systems is somewhat trivial when compared to making sure that you've got a fixed way of passing data around. So why bother to put all that effort in to structuring our data? Well, it actually gets us a lot of advantages. One of the big ones is that it helps us externalize our business mission. And by that, I mean that it forces us to define terms and agree on them at a corporate level, which means that we have the same vision of what we're trying to accomplish as a business and can represent those things. So there isn't one group talking about users and another group talking about customers when they're really meaning the same thing. We have a common vocabulary at that point, and that allows us to then understand what our business is trying to do. It gives us certainly a way to anticipate any incremental changes, because change is going to occur, and by having a formal way to deal with that through a governance process, we can then make sure that that works smoothly. And again, the whole goal of SOA is really to allow us to be flexible and agile, to let us add new components into our environment, to let us connect new, whether it's vendors or customers, directly into our systems and access our data. The goal is that agility. And in order to really gain that, we need to make sure that we understand what our data represents so that we can plug those components in quickly. Given some kind of service-oriented architecture, some way of communicating our data, let's look at workflow. And the first step of workflow is really just to understand what is workflow and where do we find it in a business. Workflow is really a definition of a set of tasks, so what people or systems are being asked to do. And those tasks get interrupted by decisions. So as the task moves forward and we, say, fill out a form, at some point a decision gets made about who that form has to go to, or whether that form's been filled out correctly, or whether that form is actually the right form to be using in that situation. So there's these decision points as we go through the process. And at the end, what we're trying to produce is information. So we're going to update a database system, or we're going to generate a PDF document of a contract. In some way, this process uses and produces information. And what's interesting is when you look at workflow, you'll find that workflow actually can be looked at in three different aspects. One is workflow where people are involved. This could be people that are asking a question of a system. It could be people responding to a question from the system. But somehow a person is charged with interacting with the computer. And that workflow process can be thought of as human-centric. So a screen is going to be rendered, or they're going to get a message on their smartphone, and they're going to have to respond to it. But somehow there's a person involved. Another type of workflow involves systems, where we want System A to pass some data to System B, and System B does some calculations and sends a response back to System A. And that is normally referred to as orchestration, system-to-system communication, but it's really workflow. There's a process going on. And then finally, we can think of processes often in terms of documents. It's very common for us to think of a document and the workflow that it goes through when a document comes into our organization and someone looks at it and interprets what it is, and they may key some data off of it, or they may pass it on to someone else and eventually resolve it and file it someplace for storage. That's a process. And so it's easy to understand why content management systems or document management systems in their early days started having workflow capabilities added to them, because it was common to want to be able to tell the system what you expected to have happen with a document. Well, what's interesting is when you look at these three major ways that workflow gets used, the workflow tools themselves tend to have strengths in different buckets. So a given workflow tool may be really good with human-centric interactions and struggle when it comes to content management. And you can vice versa. There are a few tools that do two of them very well, and I'm not aware of any that actually do all three really well. But that isn't the goal. If you step back and think about our service-oriented architecture concept, the idea is that we can take a component, take a different product, and we can plug them in so that each one does what it's good at, just like the players on our soccer team. We're not expecting our goalie to come up and play forward. That's not what's in the plan. So there shouldn't be an expectation that we're going to find one tool that does all this stuff for us. Rather, we just want to make sure that we have these tools can be in a way that can be integrated effectively. But these are the processes, these are types of processes we're going to have to find a way to manage. Now, when we're looking in our business for how we're going to leverage workflow, we have to start by looking at our current state. How do we do the work right now? And we're going to find that that involves human-to-human interactions where people are passing information around, and that could be electronically, it could be that they're doing it on paper, but one way or another, people are driving the process. Another way is that there are human and system interactions. A person's logging onto a system and looking up data, or they're responding to a phone call and looking something up, what have you. And then finally, there are system-to-system interactions. And that could be something like a batch job that runs at night and then monitors for its completion to start the next one, or a system reaching out to another system to run some kind of calculation. Maybe it's a rating engine or something of that nature, but system-to-system interactions. Those all, as we said, represent workflows. And then we can look at where we involve third parties. Where do our customers come into play? You know, customers are making phone calls coming in, or they're coming to our web portal, or whatever. Vendors may be passing us data, or we may be pulling data from vendor systems, but those all form aspects of workflow, and we need to document that. And so a question comes up, well, how do you document such a thing? And one of the effective ways to document workflow is using a SIPOC. And the goal of a SIPOC is to understand at each step in the process who is actually supplying the information that we're using, and who could be a system, it could be people, it could be reference tables printed someplace, but who's supplying this information? What are the actual inputs that are being used, representing the data that's being consumed by the process? What does the process actually do with that data? And then the outputs are, what does that process produce? Which it could be a decision, it could be new data, it could be a document. But what's that output? And then finally, who are the customers of that output? Who actually uses that output? And if I'd recommend, you know, if you just type SIPOC into Google, you'll find lots of examples. But a SIPOC diagram that shows how these connect through the entire workflow is a really powerful way to be able to understand how data flows through the system, how people are involved, where decisions are being made, and then start to look for opportunities to automate that. Now, key points that you're going to identify as you go through that exercise are places where data is accessed manually, so it isn't in a system. So there'd be no way to just automate it without somehow getting that data represented in electronic format. So understanding what's the source of that data, why isn't it in electronic format, things like that will have to be worked through. And then where are manual steps and decisions occurring? And where that knowledge apparently isn't in a system, it's in a person's head, or it's documented in a policy manual or desk procedures, but that knowledge is someplace other than in a computer system. So where is that? And then being able to then extract it and make it, put it in a system so we can automatically execute it. When you're working through that automation, there's some signals you can look for that jump out and say, hey, this is a great opportunity to think about automating. The first one is any place where you're going to an external system to look something up. And this will happen commonly with people who have multiple systems that aren't actually connected to each other. And so a person doing their job is sitting at a system doing some work, and they have to log into a second system and look something up. And that's clearly an opportunity to automate, because that's really a process, and that's an orchestration process between those systems. Any place where there's reviews going on, where something has to be passed on to someone, and they look at risk and make a yes/no type decision or a routing decision that's going to go to this person versus this person based on risk or some calculation. Another area where automation can play that role really effectively. Department handoffs are big because that tends to be where information can get lost or confused. Is within a department, things sometimes can be made to run really efficiently. But when we start crossing departmental boundaries where the groups do things in different ways and have different processes internally and even different forms that they use and what have you, we can really start to have breakdowns in communication and the closing of the loop, if you will, around work. And so that's a great opportunity to leverage automation. You'll see a couple here, the missing metrics and the traceability. And that's really about what tools allow us to do. The metrics are all about being able to actually understand what is the load. How many times is this process executed? What's waiting in the queue? Questions that can be rather difficult to answer if it's just people with piles of paper on their desk. And the traceability is huge. It's essentially a free side effect of using a tool, and that is that it records its actions. And so being able to understand why a decision was reached or the process through which something went is really powerful to have available as part of using a tool. That's exploring workflow and gathering workflow requirements. So now we need to look at the business rule side, because workflow and rules, they play well together, but they're actually two very different things. And the rules are all about the calculations and decisions that we have to make, and they have a variety of sources where we pull those. And so if we think of business rules, we can reduce them down to logic. They're some kind of computation, or the fancy term here, assertion or retraction. In other words, somehow we create information. And there's two very simple examples here on this slide. The first one, that if, it says if essentially the person is less than 18 years old, then this concept called voter card is set to no. So that's an assertion. It's called an assertion rule. It creates this piece of data called voter card with a value of no. And then that other rule there is age, and it gives a calculation. So it's a simple computation. And if you look at that, as a person, most of us would immediately realize that one of those has to be done before the other. And developers will immediately go, oh, we've got to put this in a certain order. And one of the first things that we have to get used to as we start to think about business rules is that a lot of times the order can simply be inferred by the environment. And that's as you start getting into business rules, developers need to be comfortable with the fact that, again, that level of granularity is different now, and we don't have to bother ourselves necessarily with step-by-step instructions to the computer about how to do something. The computer, the rule environment, is perfectly able to understand that it would have to calculate the age before it uses it. And so that's a power of these environments. Now, I have the word decision in parentheses because we tend to think of business rules as a place that makes decisions. But I would argue that decisions actually require something to interpret the decision and actually take an action. And business rules don't take an action. So a business rule might go through a set of computations and assertion-style rules, and it might arrive at an answer. And that answer might be yes. But the yes doesn't actually advance anything. It doesn't cause us to the loan to actually be approved or anything of that nature. It's workflow that has to interpret that result and actually move the process forward. And so that's why I think of decisions as something that really aren't made by the business rule. The business rule simply gives us information, and it's the workflow environment that then interprets it and pushes it forward. But you can certainly think of the business rule as representing the data necessary to make the decision. It just doesn't execute on the decision. So as you're exploring opportunities for using business rules and business rule tools, where do you find those rules in your current environment? Well, first and foremost, you'd find it in your business documentation. So these, again, they might be things like desk procedures, policy manuals, anything that talks about how your business operates. You'll also find business rules sitting in regulations. You're assuming that you're in an industry where there are laws that apply to how you do business. Some of those laws are going to become business rules for you. They're going to put constraints around what your systems are allowed to do and what you're allowed to do as you operate your business. You also have existing applications within your company, and those applications themselves contain business rules. As we said, over time, nothing's really changed. We've wanted computers to make decisions for us and automate pieces of processes since we've started using them. And so those existing applications have embedded within them workflow information and a significant amount of business rule information. And that has to be somehow extracted if we're going to try and make it more visible and more maintainable, as we'll talk about later on. And then finally, the information is sitting in people's heads. So those experts that actually run our business are the ones who understand how that's done and what those rules are. And so working with them to actually document that information is a key part of actually finding and codifying business rules. And so like we did with workflow, we need to talk about how are we going to codify or record these business rules in a way that the business understands that we've actually documented them correctly, and we can pass them on to a business rule environment to interpret. And I show three major ways that we've seen business rules being documented. And I'm going to start at the bottom, and I'd say this is the least desirable way to want to document business rules, and that is simply to reproduce the natural language describing the rule in ways that you might find in a policy manual. And the issue that you run into with natural language is that the terms may not be clearly defined, and they may not be used the same way from between policy manuals or policy manuals and desk procedures or what have you. And so they can be left up to some interpretation. It's also very easy in a natural language expression to leave an incomplete result, to not actually have a completely logical expression of the rule. And it's very hard sometimes to figure out whether the rule is itself complete or logical in nature. The next step that sometimes gets used is pseudocode, or you can think of it as constrained language. So we create a language that's still sort of readable, but there are some rules about how it's constructed. And so in this case, it's a simple if-then. But we still can have some question around how it fits together. So if we read this pseudocode example, it's saying if the applicant's age is less than 16, or the applicant's age is less than 17, the applicant's home state is equal to Tennessee. Well, my first issue is the or of a higher precedence than the and. In other words, is this checking the age less than 16 or age less than 17 and then applying the result of that to the home state being Tennessee? Now, most people would look at that and go, well, that doesn't make any sense because anything that's less than 17 is less than 16. Anything that's less than 16 is less than 17, so that wouldn't make any sense to apply it that way. But the fact is the statement is written. There's this ambiguity to it that we really don't want. And so at the top we have what's called a decision table. And with decision tables we can make sure that we cover the ambiguities. And in fact there are tools out there that can look at a decision table and tell you if it contains either missing information, if there are gaps in the rule in the ranges that are covered, or if there are overlaps, ambiguities of any kind. And decision tables, if you've never seen one, may look a little confusing. But in reality, people can learn to use them very quickly, and we use them with business all the time. Now, this isn't the only way or the only part of a requirements document. There would also be definitions around the workflow that's occurring. There would be use cases describing how the system is interacting with people or systems are interacting with people. So this doesn't describe the entire system. What this describes is the points where the rules themselves are being used. And you can lay decision tables out either horizontally or vertically. This one happens to be laid out vertically. Later on I'll show you an example of a horizontal one. So each rule is just a column, and we can go down and look. If you look at Rule 1, it says that the age is less than 16, then no matter what the state is, we're not going to accept the application. So it's rather straightforward once you learn to read that syntax to be able to quickly understand it. It also allows you to see the connection between certain information, like in this case age and state, and whether we're accepting an application. So there isn't a lot of mystery about what's being updated here, what information is being created versus what information is being consumed. So if you think of the SIPOC diagram, we know that age and state are inputs, and we know that the accept app is an output. And it's very clear. So decision tables are very powerful. The other advantage to a decision table is most rule environments actually have a native way to work with decision tables. And so from a traceability and training standpoint, it's very easy to then go from this structure in a requirements process into the actual design and build process of a rule environment. Some other ways that we need to think about business rules just as we're going through the process of figuring out what we're going to automate and where the best place to locate those rules would be. Is it a tool? Are we hard coding it? Are we building some one-off thing? Are we using a service and let somebody else take care of it? Come around things like the volatility. How often does the rule change? Obviously, if it changes frequently, we're going to want to make it really easy to update it. But on the flip side, if it's very sensitive information that we don't want a lot of people to have visibility to, we're going to have to think about the security around the process of maintaining it. So each of these different ways of classifying business rules tends to play a role as we think through how we're going to represent it and deal with its control. So like with the workflow, there are some signals that will jump out and identify good places for automating business rules. And the first two are exactly the same as the workflow side. Anytime we want to be able to trace why the system came to the conclusion it did, or we want to understand the metrics of how the rules are being used, we get that essentially as a side effect of using a rules-based environment. The company-wide visibility is very powerful. It's a way now that we've codified our rules such that the business can see them and they can be shared across the business, because that's our goal with the service-oriented architecture, is to connect these pieces together and be able to leverage them from between different systems. And so now they're visible. And again, from a governance perspective, we've got to have that in place so that everyone agrees on how these rules, what they say, that they align with our mission, that they align with the laws and regulations, etc. So that's valuable. The multiple channels is talking about the fact that in this day and age, we expect to be able to interact with our computer systems in a lot of different ways. So it's not just a green screen terminal hooked up to the mainframe anymore. I've got people sitting on applications, rich client applications. I've got people on web browsers who are connecting over VPNs or maybe connecting through extranet services. Others are using smartphones to connect in. So I've got different ways that people can come into the system, but I always need to produce the same answer. I always need the same workflow to occur. And so the rule engine is a great point of being able to enforce that commonality between all those different channels. And the point-in-time applicability really comes down to something called effectivity that we'll talk about as we get into the tools themselves. The next thing I want to talk about is automating the workflow in business rules. So this is actually talking about the tools, how we work with them, what they do for us, and how we glue them all together. And in order to get benefit out of these tools from an automation standpoint, we've got to get through these 6 concepts. The first one is trust, and that's really the trust the business has in the fact that we can automate this, and the trust that we have in the data and such that we're consuming and producing. We then need to make sure we can integrate these components together. We have to be able to somehow encode, meaning we have to program the systems. We have to encode the workflows. We have to encode the business rules. We have to tell the system what these rules are. We have to have some way to version this, and we'll talk a bit about why versioning becomes somewhat of a challenge, but a very important aspect of automation with these tools. And then finally, once we've got that done, we want the tool to actually execute and do the work. And then when we're comfortable that that's all working the way it's supposed to, we can broaden the applicability to other constituents. So trust is key. In the absence of trusting that these systems are doing what they're supposed to do, we tend to find businesses creating workflows that have a lot of manual intervention. And manual intervention is completely the wrong direction to go. It's going to slow everything down. And so the business has to be able to trust that when they say, yes, this decision can be automated as long as the risk threshold is below X. And they need to be able to trust that that's really going to happen. And a couple of ways that that happens is, first, we have to make sure that the business can actually read or interpret the way that we're configuring it, and we're going to talk about how these tools make that possible. And then another piece is we have to be able to audit what the system is doing, so we can prove to ourselves over time that, yes, it's doing what we expected, and if it's not, we can find ways to adjust for that. So auditing the system behavior is important. Now, at no time can the business be out of the loop with this. I've talked about governance a couple of times, and I can't stress it enough that without the business actually providing that oversight and being involved, we won't be particularly successful with automating anything, because the business has to be comfortable with that. The business houses that knowledge, and so they've got to be in that loop. Now, on the flip side, that doesn't mean that the business actually owns the development of the workflows and the rules. Sometimes when companies are looking at workflow and business rule tools, they'll tend to think that they can just hand all the responsibility to business people, take it away from IT, and that that's the advantage. I'm going to buy this tool, and I'm going to speed up the cycle that I go through to create a new application, because I won't have to involve IT people writing low-level code and integrating a bunch of systems. And that's not the case. That work has to be done. It's just we're changing the development paradigm to speed it up, but it still requires that type of resource to get the work done. So once the business trusts that that's all working, we have to integrate the components together. And we've talked about SOA as really being a straightforward way to integrate. It's not the only way to integrate. It's not a requirement of using any of these tools, but it's certainly a great way to be able to hook up workflow and rules quickly. And that canonical, as we talked about before, is a key component of that. By knowing what a piece of data represents all the time, it makes it rather straightforward when I introduce a new component like a workflow engine into my environment to be able to start making use of it quickly, because I don't have to define terms or figure out where my data is coming from. Once I have a tool, I have to program it. I have to encode the information in it. And we talked earlier about the fact that there are really 3 different use cases behind workflow. It can be human interactions with the system, it can be system to system, and it can be documents being produced or moved around in the system. And so different workflow environments will have different features to support that. So we have to make sure we have the right feature set for the work that we're trying to do. Those applications will almost always have some proprietary way of encoding their rules of their workflow. Now, there are some standards that have emerged around representing workflow and business rules. However, to say that you can go into a rule environment, create the rules, and then hit some export button and import them into a completely different rule environment, that's not feasible. So even though there are standards for communicating these rules, they aren't yet at a point where we can easily import and export and move things between different vendors' options. So when you're using one of these products, you're going to stay in that world with your solution. So once we've built out the solution, as we said, we want the business to be able to actually validate that what we've got meets what they were asking for. And certainly when we were writing code in COBOL or what have you, they couldn't do that. But this is a screenshot of a workflow environment. And here a business person can, in fact, look at this and say, yes, this meets the process that we've been discussing. Or no, this is different. This gets assigned to a different person, or there's a different decision at this point. But this is the kind of thing that these tools allow us to do, is to communicate with the business people in order to make sure that the system is going to be doing what the business expects it to be doing. And that's very powerful. On the rule side, same idea. I can represent the rules as a table, which we talked about already. Trees are another way. Decision trees are another very common way to represent rules. Again, fairly straightforward to interpret. Once you get used to looking at them, you can quickly identify if things meet the way your business wants to make a decision, or the type of, whatever the requirements were that you had edicted. So given that, we then have to deal with this versioning concept, because the rule engine and the workflow environment, they're not sitting on their own. They're integrated with databases and web services and probably some code that glues systems together. And that all needs to be versioned and rolled out in a unit. I can't roll out a new workflow that expects some piece of data to exist if I don't roll out the new XML schema that has that piece of data at the same time. And I can't roll those systems back if I have a need to a previous version if I don't understand what other parts of my environment have to be rolled back as well. Now, our goal is agility, but once those systems get out of sync, I have a problem. And so that's one of the challenges with these tools is every one of them has a way to represent versions and version control, but it's infrequent that those are integrated with standard version control systems. Like CVS or something of that nature. So instead you need to have some way, again through a governance process, a formal process, of keeping track of the versions between the different components in the architecture. Once I get all that defined and I roll out my system and it starts executing, what we really want is straight-through processing. We want work to occur where we don't have to touch it. So if you think of a self-service portal, if you've ever gotten an email maybe from your health payer who says a new claim's been submitted, click here if you want to go look at it. You click on the link and you can log in, you can look at the claim and understand how it's been paid. That's straight through processing. No one on the payer side had to worry about me looking that data up. But at the same time, we have to worry about exception processing, which is an area that people tend to forget about. But things go wrong with system-to-system interactions, data that wasn't expected. And so all these tools have some way of dealing with exceptions, but it has to be part of our process to work through that. And then those are other aspects of what we have to work with as we deal with a system that's executing our rules and workflows. Once we trust the system's doing what we want it to do, we're in a perfect position to broaden its use. So if we've built a call center application and it's working smoothly, it's not a huge leap to then start using that to supply functionality to a self-service portal, because most of what the call center reps were looking up is going to be data that someone coming from the outside would want to be looking up. And that's the power of this, is that once I have those workflows worked out, I have the rules worked out, it becomes just an incremental change to leverage them through different channels. I'm going to take a moment and just talk about point solutions. We've been talking about generic rule environments and workflow environments, but you can also purchase a point solution, something that's built for a specific industry. And the beauty of that is that the data structures are pre-built. I don't have to worry about creating a canonical for this tool or a data dictionary for this tool. It's integrated within itself, so the rules and the workflow, et cetera, all know how to talk to each other. What I lose is some flexibility, because it's only going to allow me to configure things within its scope. It's not a general purpose tool. And so as you're assessing these tools, what you really want to understand is, do I work in an industry where there's a lot of commoditization? Are the processes really common such that this tool isn't going to interfere with how I'm trying to do business? And then the 80-20 rule is helpful as a quick way just to get a look at the products and say, do I see how my business 80% of the time works the way this tool thinks I should be working, and vice versa? Do I see how I as a business would leverage 80% of the functionality in this tool? And so that starts to give me a feel for, is there a fit here, or is this really outside the bounds of being useful to me? So the advantages of leveraging a tool like this, as I said, that it's out of the box, you turn it on, the requirements have already been taken care of, they're built into the system, and what you're getting essentially as a part of that package is industry best practices. These companies have already worked with a bunch of other companies to figure out what is the best way to carry out this workflow or to set up these rules. And so they've put those in place. They've probably got the common decisions and the standard practices already built in. You don't have to worry about coding them or going around and gathering requirements around them. And then you're going to get the updates, right? As regulations change, you're not going to have to keep track of that. The vendor's going to put out new versions that include that new functionality. So you get a lot by using these industry-specific solutions. Now, what you give up is control of the environment. You won't have some of the general purpose features that you would find in just a rule engine where you can control any aspect of its behavior. The way that the data is stored and represented is probably proprietary to the tool and may not align with how you deal with your data in other systems, and so there's probably some mapping that you're going to have to do to integrate this. And then in some cases, if that 80-20 rule isn't followed, you're likely to end up with the business demanding a bunch of functionality you have to go build in a one-off fashion. So I'm just going to take a second on the fact that rule engines are actually growing way beyond what they were originally thought of doing. And just some food for thought. One is that you can use your rules to look for trends. So it's really interesting to look at rule outcomes and start to understand why the outcomes are resolving the way they are. So for instance, if you're running a loan application and you're seeing a lot of rejections, you can start to look at, are we advertising to the wrong market? Are we somehow being too conservative? You know, what's going on? So you can start to look at root causing some of this. There's a lot of functionality in these rule engines that allow you to do what-ifs, testing to understand what would happen if I made this change or if I added another set of clients or what changed my business model. The other big thing, I had to put it in here because it's really becoming a big part of rule environments, and that's complex event processing. So rules engines are starting to include this feature. The idea is to treat a set of events, a set of things that happen within your business or outside of your business, and treat them as a unit that you can make a decision about. And this is a really interesting feature and an interesting way, again, to look for opportunities for your business as its environment changes. So in closing, you've got to trust the automation. The business has to be comfortable with what this automation does, has to be able to read how it's being represented in the system. These tools are not a replacement for developers. They just change the way we develop. They're not a panacea. No one tool does everything well. They all have idiosyncrasies that will have to be worked through and understood. And training, I mentioned it up there, is huge. These tools can look really simple, and it can lead you to believe that you can just get started, just install it, turn it on, and go. But there's a lot of nuance to creating workflows and business rules in a way that scales well and holds up over time. So the training is vital. So I'd ask you to submit your questions, and I do thank you very much, and I will turn it back over to Bill.
Okay, thank you, David. And yeah, there actually are a couple of questions here. The first one, is there an insurance industry point solution available?
Yeah. Oh, yes, absolutely. There are several point solutions, some large, well-established ones, and some up-and-comers, but most definitely they exist in the market.
Okay, and the next question, what do you think is the best human-centric BPM software tool?
Well, best is difficult because they are all different. In fact, one of the things that we often do at the beginning, working with a client who wants to move into leveraging these tools, is to actually go through an assessment process where we look at how that business's infrastructure is set up, how they want to use the tool in the future, and essentially create a scorecard, and then look at the different vendor offerings and where their strengths and challenges lie. Because human-centric is a broad term and can mean different things in the different vendor tools. So there isn't really one best.
Okay, and one last question there. Who usually drives the project? Is it business or should it be IT?
Well, in our experience, we've actually seen both. We have been brought in by the business who, finds a tool that they think is going to really help them, and they'll want us to help get that rolled into IT. And we've also had IT be the one saying, look, these tools can allow us to react to the business demands quicker. In reality, neither of those works in a vacuum, and the first step we always take, no matter who brings us in, is to make sure that the IT organization and the business organization are sitting at the same table, hearing the same thing, focused on resolving the problem in the same way.
Okay, well, thank you very much, David. And for all of you, the contact information for David Reed, the Chief Technology Officer for Blue Slate, is on screen here right now. There will be an archived version of this available. We will email everybody a link in the coming days. We've come up on our full hour here, so David, thank you very much for this very insightful presentation here today.
Well, thank you very much as well.
Okay, thank you, everybody, and have a great afternoon.